This is section 9.5, which is still solving quadratic equations, but now using the quadratic formula. So this is the last new method that we're going to learn for solving quadratic equations. So to solve a quadratic equation in the form ax squared plus bx plus c equals 0, you can use the quadratic formula. So if you remember, when we were solving by square roots, there was no bx term. So now these problems have all three terms. So you have a trinomial. So you can solve by graphing, but not every quadratic is easy to graph. You can solve by factoring, which we did in the last chapter before we came into remote learning, but not every quadratic is factorable. So you have two other methods that might be difficult or not possible to use. And again, square roots you can't use if there's that bx term. So what's left is now your quadratic formula. So you can use this to solve every single quadratic equation. Doesn't matter what the equation looks like, you can use your quadratic formula. But you have to make sure it's set equal to 0, just like factoring, in order to use your quadratic formula. So what is it? You have this formula here that might look a little scary to you, but it's actually very simple to use, and it's very, very important. So you're going to need to know this formula for Algebra 1, going into Algebra 2, higher level maths, SATs. You're going to need to know this formula and how to use it. So the formula is x equals, so again, we're solving for x as we've been doing. So what we're doing is we're looking for those x-intercepts if we had our graph. Negative b plus or minus the square root b squared minus 4ac all over 2a. So again, you need to know how to use this formula. This is a very important formula. We're going to be spending a lot of time using it, practicing, and making sure we all understand it. First example. So as you can see, my quadratic is set equal to 0, which is necessary in order to use your quadratic formula. So if your equation was not set equal to 0, you would have to rearrange, add or subtract in order to get it equal to 0. So what are our A term, B term, C term? So when you're first starting off using your quadratic formula, it's helpful to write out what A is, what B is, and what C is, so you can just plug it in and you don't have to go back and look at the equation. So A is 2, B is negative 5. Yes, you have to include that negative sign. C is 3. Also, what I recommend when you first start using the formula is rewrite the formula every time. It allows you to start memorizing it, and it helps you see what to plug in to where. So I would write down the formula when you start every single problem. So you're going to plug everything in. So negative b, you're going to plug in that negative 5. B squared, plug in that negative 5. Again, I'm putting parentheses around here because when you put it into your calculator, you also need to put parentheses around it because negative 5 squared is going to be a positive 25. And if you don't put the parentheses around it, your calculator will tell you it's negative 25. Okay, so just be mindful of that. Subtracting 4 times A. A is 2, so you're plugging in 2 for A. Times C, you're plugging in 3 for C. And the whole thing, the whole equation, is being divided by 2 times A. So 2 times 2. Now that you plugged everything in, you want to start simplifying. I recommend you start simplifying inside that radical before you move out. Okay, so how did I go from here to here? Well, 2 negatives, as you should know, is a positive 5. Negative 5 squared is positive 25. 4 times 2 is 8. 8 times 3, 24. You have that minus sign still. Subtract eventually, and then in your denominator you have 2 times 2, which is 4. So now I'm going to subtract inside my radical, so 25 minus 4 gives me 1. Didn't do anything else, so don't touch any of the other numbers. Now, can you take the square root of 1? Yes, because 1 is a perfect square root, leaving you with 1. So just like when you were solving by square roots before, you had two answers. You had your positive and your negative. So when you have your quadratic equation and you're using your quadratic formula, you also have two solutions as well, both that positive and the negative. Well, now we want to see what the positive and the negative solutions would be. So you split it up into two cases, one where you're adding and then one where you're subtracting. So 5 plus 1 and then 5 minus 1. Both of them, again, are still divided by 4. So 5 plus 1 would give you 6. 5 minus 1 would give you 4. So again, two separate answers that you're simplifying. So for the first one, you have 6 over 4, which you can reduce into 3 over 2. And then 4 over 4, you can reduce to 1. So your two solutions are x equals 3 over 2 or x equals 1. So what you want to do is just plug the numbers in, and it's fairly simple. It might look confusing, might look like a lot of steps, but it's actually really simple once you get the hang of it. Let's look at example 2. So now for this example, hopefully you notice it is not set equal to 0. So before you start plugging into your quadratic formula, you have to set it equal to 0. So you're going to add 5 to each side. Now you have x squared plus 6x plus 5 equaling 0. Set equal to 0. Now you can go ahead and use your quadratic formula. So list out A, list out B, list out C. Again, it's a little helpful when you go to plug it in to list them all out so you actually know what A is, what B is, and what C is. Write the formula and start plugging everything in. So what is B? B is 6 plus or minus the square root. B squared. What is B? 6 again. So you have 6 squared minus 4 times A. What is A? 1 times C. What is C? 5 divided by 2 times A. And what did we say A was? A is 1. Now we want to simplify. So negative 6 plus or minus square root 6 squared gave us 36 minus 4 times 1 times 5 would be minus 20 over 2 times 1, which is just 2. So now you could subtract 36 minus 20, and it gives you 16. Well, 16 is another perfect square root. So what can we do? We can now take the square root of 16, and now we get 4. So you have negative 6 plus or minus 4, all divided by 2. Now, split it into two cases, one where you're adding 4 and one where you're subtracting 4. So now you can continue to solve for your two solutions. So negative 6 plus 4 and then negative 6 minus 4. You get negative 2 over 2, negative 10 over 2, divide, you get negative 1 and negative 5. So what are our two solutions? X equals negative 1 or x equals negative 5. What you have to remember to do is set it equal to 0 before you start plugging in, because if you plug in the negative 5, that actually changes the entire problem. So you have to make sure it's set equal to 0 first. Okay, our next example. We want to solve x squared equals 7x using the quadratic formula. So set it equal to 0 first. So you're going to subtract 7x from both sides. Well, hopefully you notice there's only two terms. You have your A, you have your B. Well, what's your C? A is 1, B would be negative 7. That should be a negative sign. And then C would be 0. Take them, plug them in. So you're going to plug in negative 7 in for B. Again, negative 7 in for B. 1 in for A. But because there was no C term, we said C was 0. So you're going to plug in 0 for C. Simplify just like we've been doing in the last example. So two negatives would give you a positive 7. Negative 7 squared is going to give you 49. Now, if you multiply negative 4 times 1 times 0, you're really going to be subtracting 0. So you really just have 7 plus or minus the square root of 49 over 2. 49, another perfect square root. Simplify that. So you have 7 plus or minus 7 divided by 2. Split it up into your two cases, one where you're going to add 7, one where you're going to subtract 7. So 7 plus 7 is going to give you 14 over 2, and then 7 minus 7 is going to give you 0 over 2. So your two solutions are going to be 7 and 0. Now let's think back real quick to some factoring. So factoring sometimes might be easier. So you have to remember all the different methods. Now you can use quadratic formula on everything, but factoring would be so much easier on this example. So I just want to recall factoring just to remind you what you could do. So for this problem, hopefully you notice that both terms have an x value. So that's actually your greatest common factor. And you can factor out that x, leaving you with just x minus 7. This is fully factored, and what you can do when your equation is set equal to 0, you can use that zero product property where you're going to set x equal to 0 and then x minus 7 equal to 0. So you have that one solution already. Add 7 to both sides, and you get the second one. So quadratic formula will work for every problem, but I just wanted to recall and remind you about factoring because sometimes it is easier and you really shouldn't forget factoring just because we moved on to another section. So those were 3 examples going over the quadratic formula, and there's more examples to come.